the point where we wrote down those two equations. What were them? 5s plus 7r equal to 153 and 7s plus 5r equal to 147. From that point onwards, whatever we have done is equation solving. Simple equation solving where the equations are linear equations. Now you can notice one thing, that is, after formulating these two equations, during the solution we did not have to care about what S and R stand for. S is the price of 1 kilogram of sugar, R is the price of 1 kilogram of rice. We did not have to think about that. We can just simply forget what S and R are, and we can solve the equation, and once we have found the values of S and R, we can then go back to find the actual cost of, we can solve the problem. We can start reinterpreting what these values of the variables, what the variables mean, and what ultimately we get. So the point I am trying to make here is that starting from these equations to this is the pure mathematics part. Everything else about the problem is applied mathematics. You see, to solve this problem, we have used the theory of linear equations. That is mathematics. And the decision to use this part of mathematics to solve the problem is applied mathematics. So people who deal with this part, they are called pure mathematicians, and people who deal with the actual problem, they are called applied mathematicians. So that is the distinction between pure and applied mathematics. And speaking of pure mathematics, of course, mathematicians would not consider these two equations. They would consider something like this. Instead of these concrete numbers here, they would consider equations that look like this. A, I, S, let's keep the variables name the same to help you understand the link, equal to C, ds plus ER equal to F, where these A, B, C, D, E, F, these are some numbers, any number, and S and R are variables. They try to solve this type of systems. In the most general case, they would not, of course, also solve this. In mathematics, while practicing mathematics, the tendency is to be as general as possible so that all cases and all situations are covered. So, while discussing systems of linear equations, we tend to take, but we take as many variables as we can and as many equations as we can. And that number is also not fixed. So mathematicians would consider m equations, m number of equations in n number of variables, where m and n can take any value. So such a system would look like this. A11, I will explain what these things mean. A12 x2 plus A1n xn equal to B1, then A21 x1 plus A22 x2 A2n xn equal to B2, and it goes on. Eventually we reach a m1 x1 plus plus a m2 x2 plus a mn xn equal to bm. Now this is also a system of equations like this one, but here things look quite complicated. Let me explain the meaning of these symbols. Here this is not 11. Recall that I was saying A11, A21, this is not 21. A11 means, okay, by the way, what are these? These are the numbers, or these numbers. Okay, these can be any numbers. So if I write them within circles, you can more clearly see what I mean. These are also numbers. These are, for example, 153, 147, like that. Now, here we have two variables, s and r. Here we have n variables, where n can be 2, 3, 10, 100, 1 million, 1 trillion, any number of variables can be there. Similarly, any number of equations can be there, and they need not even be the same. Here they are same, two variables, two equations, but in general that need not be the case. So here what these numbers mean, the first number that appears indicates the equation where it is appearing. 1 is appearing in all these numbers because these constants or these numbers are appearing in the first equation. The second number indicates the coefficient, indicates the variable to which this is a coefficient, this number. So A11 is the coefficient of the first variable in the first equation. A12 is the coefficient of the second variable in the first equation, and so on. So for example, AMN is the coefficient of the nth variable in the nth equation. So people like pure